This illustration deals with the number of outlets on a circuit in accordance with 210.11a. Now, notice at the very top of the illustration, there's a question there. How many outlets could you basically put on, say, a 15 amp circuit in residential properties? Now, we previously showed 600 square foot, and this is how that square foot was obtained. Step one, finding the square foot. And 210.11b is in boy. And then using 220.14, say L and J, we could find the square footage by taking 120 volts times a 15 amp circuit breaker on number 14 wire and dividing it by 3 VA listed in 220.14J, and you'd come up with 600 square foot, and there's just not any number restriction there by code now, but it might be by state, county, city, or the installing contractor, because they wouldn't want nuisance tripping. Now, step two, when I say nuisance tripping, to a homeowner, if a receptacle's on the wall anywhere, it's eligible to be plugged into. And remember, they do not have electrical knowledge, and they think any receptacle on the wall, they can plug into it. And sometimes they overload the circuit with not limiting the number of outlets, which some states, counties, and cities will do. Now, the next illustration, below it, there's another question. How many outlets basically could be put on a commercial? And notice these receptacles in this commercial facility, they're non-continuous operated type in the question on 120 volt circuit. The same thing is applied here. We would go to our 220.14J and L and 210.11B, and again, we have to find how many outlets. But here's a whole different approach. We're not using 3VA. We're coming in and taking the circuit square foot device to obtain that and dividing by 1.5 amps, that we obtained by taking 180 VA per outlet divided by 120 that you saw in the previous illustration. So we would take that 15 amp overcurrent device with number 14 wire, divide it by 1.5, and you're allowed 10. But if it happened to be continuous, then you take 1.5 times 125% and divide by 2.25, I believe it is, into the 15 amps. And you can see that's going to drop it down to probably maybe 8 circuits. I don't know, you'd have to do the math to find out. But non-continuous, here we'd have 10. Now, in commercial and industrial locations, electricians have to be very careful with this. They just shouldn't go in and start adding receptacles and lighting loads on a branch circuit, because you're limited here based upon non-continuous or continuous operation as defined in Article 100. But in a dwelling unit, if the state, county, or city do not limit the number of outlets, now you can go in and add outlets for lights and stuff in that square footage area. How many rooms fall within this 600 square foot? That's what the electrician's supposed to know. And unfortunately, we have so many electricians that just don't know this, and they should apply themselves better. But we have electricians today that just won't do it without the state makes them take code review to renew their license and so forth. That, to me, is not a electrician that is knowledgeable to go out and work for the public. So you should review this. If your job is to go out and add these receptacles in, or somebody in a commercial, industrial, or area, you're doing construction work and they want them added, see if they can be added. And if you don't know, we'll check with your foreman. If they don't know, then the foreman will check with whoever has a responsibility of the plans for that job. So knowledge is something that an electrician should know, because you're wiring things for the public and you need to know how to wire them safely. And this illustration 10-5B is illustrating the number of outlets permitted on a 15 or 20 amp circuit in a commercial or industrial type installation.